All right, it's Thursday. Sounds like we're fixing to get some weather here in a few minutes, a little bit somewhere in there. Um, they're talking hail and tornadoes again. We'll see. We'll see if any of that happens or if it jumps over us like normal. If I had to bet money, I bet it jumps over us. But just in case. So anyhow, next step on this project, I went and got got my jam nuts I need. Did my Maybach box show up? No Maybach box. Hopefully that shows up tomorrow. I ordered that stuff on Monday. My stuff from Shoop should be here tomorrow, because I shipped this morning. So really I'm just waiting on stuff from Maybach. I got all my bolts that I should need. Obviously bushings are all done. We did that. The bolts are going to be done, or the draw bolts are going to be done here in a minute or an hour, one of the two. So really, as long as my stuff from Maybach shows up, as far as I know, so I got wheel bearings from Shoop. I got bearings for the crumbler from Shoop, all in that order. So barring finding any other dumb shit while it's going back together, should have everything. At least it should be on its way. So with that being said, we're gonna start threading these draw bolts. This is Dad's rigid 300 pipe threader. I probably started running this thing when I was 6, maybe 7 years old. He taught me to thread pipe on it. And I think the only time I've actually thread bolts on it was when we did those big tie rods when we put the rear hitch on the finisher. We made tie rods that went from the hitch all the way to the front of the frame to the drawbar. That way we're not pulling through the frame, we're actually pulling through those tie rods. That's the only time I ever remember me threading bolts with this thing. And Dad's done it one other time before, but he's got the dies for it, so. But it's going to be a little bit of trial and error. By all rights, you come down and you should have to line this line up with this bolt line on the die carrier. And it should be right. If you'll see, the line is off a little bit, and I set it up. I took this one that's already done and clamped it in there where it was good, where it felt good. So this is a sacrificial piece. This is one of the end cutoffs from cutting those, and we're going to test thread this and thread a nut on there and make sure it's kosher before we go ruining any good parts. So, and I don't think this thing's, oh, for some reason I thought that was aluminum. I guess not. So we close our die up, which it is. And then that down there is a dual purpose chip bucket / it's got cutting oil in the bottom of it, and then you get this handy dandy little squirter here. So bring my foot pedal is on the wrong side. Like I say, I've only ever thread bolts with this thing one time, and it's been, shoot, we bought that finisher in what, 2018? I think I bought the tractor in 17. So it's been a hot minute, but let me get a nut here. See how this threads on. Okay, that fits. So let's pull this out of the way. And let's try, just to make sure, let's try one of these guys. I mean, if a bolt fits, it should fit on here, but better safe than sorry. I can live with that. The bolt fits a little tighter than this. So I think, or sorry, the nut fits a little tighter than that. Let's try that one more. I think I can live with that. Alright. Sacrificial piece has served its purpose, so I guess we can just start threading regular, or threading for real. Alright, this is an actual, I threaded one end. I opened the dies up just at like the width of the line on the scale to try to tighten the threads up a little bit, because obviously you open the jaws up, you remove a little bit less material. And I was a lot happier with that, how that felt, versus our test. So that's the route we're gonna go with. Go till it's a couple threads outside the die. That's one done, and we'll compare that to need to go further. I may end up just marking these to make it easier. But it's easy to, you just stick it back in and you set the die down on the, go in, clamp the die down on the threads to pick them right back up, and then you keep running in. It's easy. Alright, they are all threaded. That was a lot of threading. Tell you what, cutting threads, pipe, bolts, whatever you're cutting on, it's just a very nasty, dirty, oily job. But they're all threaded, cleaned up. Just got to deburr them, so we come back over here to this jibby jabby. Guys are done. We have to make a fixture or a jig or whatever you want to call it to get a hold of those guys so that we can hold on to them. If anybody else has got the problem, but here lately about every day, like 2:30, 3 o'clock, my back gets to the point where it feels about like somebody's driving a spike in between my right shoulder blade and my spine, and man, does it hurt. I probably need to go check that out, but who's got time to go to the doctor? It's not bad when I run equipment, but like when I'm gonna go to work and I'm on my feet all day, boy, does it get real bad. Okay, so what we're gonna have to do man, it'd be nice to not have to use the vise. but actually, what if because we could do it like this. Because the problem within the vise, well, in order to get it to where we're going to be located every time, we have to make something that's going to come here, like some sort of V-block or something that can come in here and pinch this from both sides, so you got a good hold on it, and this is really the only thing you can get a hold of and be on location at the center of the hole every time. So if we put it in the vise, you're gonna hit, like, the vise is in the way to try to through drill the hole, or through ream the hole, since we're running a reamer. But if we do this, if we do something where we can take a 1, 2, 3 block and set it like that so that we're off the table, and really I only need 1 V block, which you'd probably want to do it, so we'd probably want to go this way with it so that I'm back here. And if we make it where I could bolt through the V block to the T slot and just clamp the block down tight, and then make it where I can get on here with a clamp, and we use that 1, 2, 3 block as a level, which in theory, if the V block is made level, the V block is going to automatically level it when you sink it into the V block anyhow. So, okay, I think I got an idea. Alright, first thing we got to do in order to make our tool is put a 1.25 inch hole in this piece of 1.5 inch by 1.5 inch square stock that was down in the scrap. Well, I guess not technically scrap, but where we keep all of the cutoffs. Now that our hole is in it, we're going to come over here and we're going to cut the hole at the center line. Didn't mean to do that. Alright, so cut, deburred. You can probably see where I'm going here. So basically what this is going to let us do, come in from the back like this, and then this will be something just to help keep the clamp square. Should be able to use a C-clamp or something to that if you can't twist clamp, whatever works. And clamp it like that, and between the saw kerf and whatever I ground off deburring it, put a gap in there so that we know we're getting a good tight clamp. So the next step is going to be measure out wherever I can saw this off, and we are going to weld a T-plate down here with some bolt holes in it. So I thought about just drilling 1 bolt hole, but then that would allow this thing to, if by chance it gets bumped or something, possibly walk like this on the mill table. So if I put a T on here with 2 bolt holes, then all of a sudden it can't do this. You're held. Probably overkill. It shouldn't move around, but better safe than sorry. And the same thing, once you get a decent setup, for the most part, the reamer should be self-aligning, but the more better we can make it, the better. So that's going to be where we're going to pick up tomorrow, because it's 8 o'clock. I'm hungry. My back hurts. So, yeah. Got a plan. Decent progress tonight. So, we will catch you guys tomorrow. Alright, it's Friday. I got my thing finished. Shouldn't even need a 1, 2, 3 block under it. It's plenty freaking stout. And I made it. It was completely by accident. This was just a piece of scrap that, well, this whole thing was made out of just scrap chunks we had laying down in the off-cut pile. And that was nice and heavy because I wanted something that wasn't going to twist with when you're pushing on it with the reamer. Not that you should have to put a lot of force on it, but, you know, better safe than sorry. And I need a little bit more height out of it to clear this. Well, what just so happened, we had a Joe block. It's the other one of these. This guy. And it just so happened that the bolts for the hole spread in that, I didn't do it on purpose because I was just going to like shove one in between the bolt holes like this. And the bolt pattern is the same spread as that, so that worked out perfect. So I just stuffed it on there, and there she sits. So basically at this point we're all ready to get set up here and start doing some reaming. Something about like that. Alright, I found a transfer punch that fit so I could line up the hole at least as good as it needs to be. So that's set. This is a 1-inch carbide tipped adjustable reamer. It's a salty booger, but it's kind of what we needed for this. So I think even for McMaster Card it was like $170. Alright, I already ran 2 as kind of the test run. Had to make an adjustment after the first one to kind of center up on the hole a little better. Basically just went and centered off of the jig instead of the hole itself. But other than that, made some speed changes as far as how fast we're running it, and seems to be working fairly okay. So then we come over here. And it's still, it'd be nice to have a chamfering bit with a little bit more of a rake angle to it, because it still leaves a little bit of a burr. But you shove a bushing through it and it knocks the burr off. And once the burr's gone, they slide right on through. There we go. So nice and loose once that little bit of a burr is raked off. Well, nice and loose within reason. It doesn't wobble around, which is what we're trying to avoid. So now I just have to do this a bunch more times. All right, that's all 31 of these bored out. It went about as good as could be expected for as bad as they were, and the jig worked pretty much flawlessly. Didn't really have any issues with it, albeit the C-clamp was a little clunky, but it's not like we're production machining and it needed to be fast and convenient. We just needed to do 31, and then it'll probably never get used again. So with that, we are on to, and it's not going to happen tonight, it'll be a tomorrow morning thing. We have to make a jig now to do these guys, which I think that's going to be fairly simple. I will probably just make or get a piece of round stock. I'm thinking drill and tap a hole in it for 5/8 11, run a piece of threaded rod into it and Loctite it. And then basically the reason I'll use round stock is get it out of the vise, run this onto the threaded rod and jam it tight, and then just lay a level across, because I mean, it ain't got to be perfect, it's a piece of farm equipment. Just lay a level across here and then put an end stop so that you butt the round stock up to the same place every time, and that sets your datum in and out, and then you'll always be on center. And this can just hang over like this and level it out, reclamp it, bore it, and then take it back out, bust it loose from the round stock. And I think that's going to be the simplest, easiest way to do it. And the reason for the round stock is there's obviously these aren't all going to be threaded to the exact same point. So like if you didn't use round stock or something, you could have one that would be perfectly flat when it bottomed out. You could have one that could be clocked like this when it's just, so if you use round stock, jam it in there, and then you can use the round stock and just adjust it where you need it to be. And that will be fairly quick and easy to make. So I'm going to put this stuff away, kind of blow the mill off. There ain't no sense in cleaning the floor up, because I'm going to make a bunch more chips tomorrow. Then clean it up tomorrow after I'm done doing all my machining. The only thing that sucks, and I got to call them in the morning, my parts from Maybaugh didn't show up. All my stuff from Shoot showed up. I got all my bolts. I got all my bearings. And it wouldn't be a big deal except for the fact that I went and got my axle seals from Maybaugh. Can't do the wheel bearings without the axle seals. So I gotta call them in the morning and figure out if that shipped yet or what the deal is with that, because it's been a week and normally they're not, unless getting those shanks was proved to be difficult for some reason. But anyhow, we will pick up tomorrow, and hopefully everything goes well, and hopefully by tomorrow we are putting shanks back together. Would be ideal. So we'll catch you guys tomorrow. All right. So we've got obviously all these guys are machined. Now we've got to start working on these guys. we need that tool. And you want to know what's nifty? I'm not even gonna have to make a tool or make a holder. Remember them axle stubs out of that rake? I saved them. And they just so happen to have a 5/8 11 hole in the end. Boom, tool. Just gotta cut a hunk of threaded rod off so they have something to thread that onto there and jam it so that it stays tight, and we're good to go. So let me do that real quick. Alright, so I got my first one. This is the one that I originally machined when I fixed the busted shank last year. I set up on this one because it was, I'm just going to make all of them based off of centering up on this one. So I set up, this was basically just a skim cut because apparently when I machine, or when I bored it, I'd stop just shy of whatever, what's this supposed to be, inch and 3/16. Yeah, inch and 3/16. I stopped literally just shy of it. But inch and 3/16 annular cutter, carbide tip, because this stuff is tough. But first one's done, so we'll show you the setup here. It's kind of clunky, but for the number of them that I have to do, and the fact that it's probably only, and I'm going to just real quick clean any paint scale or whatever off the end of it. Just so we don't hurt anything, let's take this over and we'll tighten it up. Like I say, this is kind of clunky, but we're not production machining. We just got to do 31 of them and then be done. And we're going to jam this. So that it stays tight. We're gonna come over here. I got an end stop for my insertion depth and lay a level on it, and that's gonna get us close enough for what it needs to be. I wonder if I'm just gonna have to do each one of these kind of custom, because like that one there, it doesn't look like I'm gonna clean the hole all the way up if I go right there. Or do I just make them all the same and whatever happens, happens? We really don't want to sneak it any further that way, because that's going to throw off once you tighten everything up. And it's amazing what little bit of difference, I mean, by the time you add everything up, it's a fair bit of difference, but the further that way it goes towards the spring, the more it rocks that shank back. So you don't really want to go that way if you don't have to. And that's the problem, is none of these are wore the same. I think some of them are clean up okay, and then you got like that one there, that one might not. So I think I'm just gonna go off of my baseline, and I think I'll just make them. I'll do what I can with them, because otherwise at that point you got to make every single one custom. And we don't really want to do that either. Let's do this one like this, and we'll see what it looks like in the end. There does come a point where it's just a piece of farm equipment. Apparently this doesn't create a whole lot of heat when it's cut. That one's off. I think we're gonna have to do every one of these kind of somewhat custom, or like as far as where we set up on it. I think our end yeah, our end looks good. It's this way. Which I guess looking at it even on this one's offset this way. And who the hell knows, when these things were new, the hole might not, depending on if the hole, because I don't know if these things are cast or forged. Judging by the chips I'm making, I'm guessing they're cast, but I mean, that hole might not have even been on center. It might have just been close enough. Yeah, they gotta be cast, otherwise that part number wouldn't be able to be there. A forging wouldn't allow that to happen. So, I think I might have to, at least this way, kind of center up on each one individually. But there's no real way to get a hold of them to get anything repeatable, because this is tapered. This is, well, you can't hold it this way, or you couldn't. We'll just set up on each one roughly individually, and it'll be what it'll be. Like I say, we're not doing thousands of these. We just got to do 31 of them, so it'll be what it'll be. All right, I'm on my last one. It took me about 4 of them to come up with a process. I haven't had to move the X at all. It's been pretty much dead on. The length on these must be pretty consistent. I've had to mess with the Y every once in a while, like this one's going to need it. Some of these, it would be interesting to see how they jigged these things at the factory when they were actually making them in a production setting, because some of these things, you thread them on there and they are just wobbling all over because the hole's not straight. So basically I just started measuring or checking every one just to make sure we were somewhat more centered than we were. And it's been working out decent. But other than that, they've all been cutting really good. Some of them clean up better than others. There's some that are really bad. But there's not a whole lot I can do about it, because it's hard to tell exactly what these things are made out of. They kind of machine like cast iron, so they don't really make a chip. And they machine kind of dull. They're not, like if it was cast steel, they would still machine to kind of a sheen, and these don't. But they're also tough, so it's got to be some sort of weird cast alloy to make them wear better. So I don't know. Also, this turned into a 2-pass process, because that makes it basically on size for these bushings. So I have a boring bar set up. And this is set up and locked in to just come in and make a skim cut and cut a little clearance into that so that it's a little bit more of a slit fit. But anyhow, about the only way to fix some of these possibly would be to go in and weld that into the hole and build it back up. But not knowing exactly what they're made out of and not having one to play with, I'm not willing to go in there and try to weld on one and ruin it yet. These things wouldn't be too terribly hard to just make completely new out of steel. They'd obviously have to be a weldment. Like, you make this out of flat stock, punch your hole in it. In order to get the strength in it, you would almost just have to get whatever this diameter is, probably about 2.5 inches, whatever, get some bar stock and just machine this and then weld this on it. So, I mean, it wouldn't be too terribly hard to make. It would just be very time consuming if I had to go in and make every single one of them new, which may turn out to be what ends up happening. But I timed them, and it was taking me roughly about, well, somewhere between 3.5 minutes and 3 minutes 45 seconds per part. And that was taking it out of the vise, coming over here, swapping them out on the mandrel, going back, getting set back up, and then running both passes. So, not terrible. Be terrible in a production setting, but for what we're doing here, not terrible. So, like that one there, that one, and you still got a little washed out spot there and there, but that at least machined it flat all the way through. And then you got some, I think this guy right here is the absolute, this is the hands down the worst one out of the whole deal. And you can see how bad the shank was bearing down on that flange. So it's still got a big washout right there in it, but like there's just not, you can't machine any more material out of it. We're already taking about all I would be comfortable taking out of it. But I mean, it's a piece of farm equipment. Like I say, if it comes down to it, we can just make some of these new out of steel. I'd just prefer to not to right now, because it's, like I say, that would be very, very time consuming. That would be almost one of them things where I'd have to find somebody with a CNC, give them, I mean, these would be quick and easy enough to make, but machining a bunch of these things on that would just be, ugh. So you'd almost have to find somebody with a CNC that could come in, because CNCs are so much faster. I mean, obviously they're faster because they're computer controlled, but not only that, they can run higher spindle speeds, better tooling. Like that thing right there, we run carbide tooling in it, but it was made, I can't remember what year that is. I know that's older than that, and that's a 66. I want to say that one's a 40 something. But that was made before carbide tooling was even a dream. That's high-speed steel days. So that thing can't even really turn enough spindle speed to take full advantage of carbide tooling. But like if you can have somebody set up on a CNC and turn that diameter and then come back in and drill and tap that hole in one setup, that would be, and they could probably turn those out a couple 2-3 minutes a piece versus probably 10 to 15 minutes a piece on that thing times 31. But they're good enough for what we got to do. So with that being said, that completes all the machining that I know of. Freaking spam calls. That's why I'm glad I don't have a house phone. I just do everything off my cell phone, and I used to get a bunch of, everybody remembers we were calling about the extended warranty on your vehicle. I used to get those all the time, and I haven't got a spam call in a long time. But anyhow, I'm gonna see if Dad's gonna do any machining, and if not, I will clean my mess up, and then we're gonna bring parts up here and start assembling shanks. I did call Maybach this morning. My stuff has not shipped yet because they're waiting. Apparently the axle seals for that thing were on back order. I wish I'd have known that, because I would have had them at least send the shanks. But I'm going to tonight pull up the part number out of the book for those seals, see if I can source them online or something. And see if I can get them coming that way. And I told them send the shanks Monday because I need those. And then if I can find those things online, I'll just order them online and cancel them from Maybach. They can't tell me when they're going to get them. So anyhow, let me get my mess cleaned up, tools put away, and we'll start putting these things together. Alright, so before we start making some sub-assemblies, we're going to see if any of these kind of more bent shanks will straighten out. So I've got, this guy here is a good one. Good. So we're going to see if I can just massage it kind of somewhat back into A shape. I don't expect it to be perfect, but if I can get it a little bit better than what it is. I'll be dang, it kind of tries to stay. Do a little bit harder than that, though. Before that door slams shut. I just don't... When you're working with spring steel, you never know how much is going to make it just explode in your face. Okay, that's mostly agreeable on this end. I just need to see if I can get it. A little more better. Right there. Except I can't press on it right there because it's going to, I have to turn this thing around because it's hitting my valve. Overbend it a little. I mean, considering where it started, I'd say it's close enough. I think we're going to be able to make this work. Well, color me impressed. Those were all the bent ones compared to one that, at least as far as I know, isn't really bent. And they all came right back to where about they should be. Now, whether or not they stay there, because they may have taken on a, when they got hook rocks, whatever caused them to go rink and open up, they may have stress at them now that makes them want to go back to that shape. Who knows, but we shall see. So now that these are all straightened out, we can start putting some stuff back together. All right, I'm just going to start making sub-assemblies versus doing one in its entirety at a time. That way we're not juggling a bunch of tools all at the same time and all the stuff that comes with trying to do a bunch of stuff at once. So, start off by assembling our shanks. Don't need it on that setting for 1/2-inch bolts anyhow. Alright, I got 29 assembled. I got one good shank left, and then I'm still waiting. I need one of the two that I ordered. But these two, I don't know exactly why somebody went at this particular area of both of them with a torch. Because there's nothing there that would have needed torched out. Like the bolts here, and there's nothing. I don't know. So, I'm going to try to make an attempt to clean those out and weld that back up somehow. Not going to be fun. Alright, these two, well, I got the last one put together already, but oopsie. They fixed a little ugly, but you'll have that when you're trying to fill in a 1/2 inch Might have even been thicker than that up in here, but that was a big gap. And I thought I had it cleaned out, and then I was welding it, I kept hitting slag from the torch. But better than what they were, which was a big gaping hole. So now we can start putting those on those with these. Oh man, I gotta dig my bolts out. Alright, before I went too far, I tried to do a complete assembly. And in order for everything to work out right, we're gonna have to pre-assemble this and the spring and everything on here. Otherwise, this doesn't articulate down correctly in order to get through here. So we're gonna have to, should be able to just set all that up in the vise. Alright, we got 2 sub-assemblies made. And then, I don't know if you can, probably, yeah, you can tell from this high up. Which one of those 3 is different? Probably that guy. I didn't notice it when I was taking them apart, but definitely noticed it putting them back together. This spring is the wrong number of coils, the wrong wire size, the wrong OD, the wrong length. So this is not even the correct spring. So I'll have to see if I can get the correct one coming, because it won't even, it's not even going to tighten up right. But I threw it together for now, just so we have it together. But, well, it's 5:30 now, and I told Shelly I'd take her to dinner, so. Plus, I got to go get some more anti-seize for Dad, because we're about out. And there was some, oh, I got to get some new clear safety glasses, because my pair that I've had, well, these are the safety glasses that I've been wearing in here since I was old enough to help Dad work out here. So they're going on like at least 20 years old, and that's not fog or anything. They're just so scratched up anymore I can't hardly see through them. So it's time to replace those. And if you want to get technical about it, there's probably some stupid OSHA standard about some sort of lifespan for safety goggles. But anyhow, let's what's going to be the best way to do this? Now that Dad's done using the big bench, we'll throw one together over here, huh? We need one of those, and one of these, and this, and this, and this, and that, and that, and this. And then these. probably this. That's better. Oh, hey. I help if I tilt you up some, huh? Not like that. And then I'll probably have to, once they're on the finisher and I got the shovels on them, might have to adjust this a little bit to get the shovels running a little or more parallel with the ground. But that's a hell of a lot tighter than what we started out with. I can tell you that much right now. Let's grab some more parts here. Where did I put my other box? Where's my, oh, there's my other box of parts. I suppose I could just wheel this thing over there versus carrying this crap back and forth every time. This thing's gonna feel like an entirely different machine. Well, it's not gonna feel like an entirely different machine because I don't know. It might actually pull easier because you'd think you take them shovels, they're supposed to run on the ground like this, and make them run on the ground like that. You'd think it'd make them pull harder. So it might pull easier, and it sure as shit has to leave a better finish, I would think. So they had locking nuts originally, and for some, well, they had the kind of locking nuts where it was just a regular hex nut, and then they dimpled 3 sides of it to squeeze it shut. And they still ran lock washers. I'm using actual stover nuts and eliminating the lock washers just because that's one less thing to fail. And slam them back together a lot quicker than they came apart, that's for damn sure. Alright, there's 9 of them put together, so they go pretty quick. But it's time to get things cleaned up, put away, so I can get home to Shelly. So tomorrow, probably work on this in the afternoon. Tomorrow morning, I gotta go pick up round balers. So heading down to Newton County, Indiana. See a college buddy. So that's gonna be what we're gonna do tomorrow morning, and then hopefully I get home at a decent time. We're gonna try to get down there in the morning if it loads easy. We'll be in and out of there in no time. Might stay down there and have lunch with them. And then get back and get it unloaded and go back to this. So, but that's a good stopping point for today. So with that being said, that's it for this one. We'll catch you guys on the next one.